Hi everyone. This is an example of how we can use acid equilibrium to calculate the pH. Here we have a question. Calculate the pH of a sample of vinegar that contains 0.83 moles of ethanoic acid. This is an acid equilibrium question. We do have a weak acid, ethanoic acid. We must work our way through the Ka expression to arrive at the pH. We have Ka is equal to hydronium ion concentration squared over Ha. Importantly, this is a contrast from when we have to solve for the Ka itself. When we're solving for the Ka itself, we're using a modified version of this formula to bypass the icebox. If we are being asked to solve for the H3O+, the Ha, or like this question, the pH, this is the version of the formula that we must use. To solve for the pH, our first step is to manipulate this equation to solve for the hydronium ion concentration. Here, the hydronium ion concentration is equal to Ka multiplied by Ha. We're going to take the root of that whole thing. From there, it's quite doable. So we have, this is equal to the Ka. When we read the question, the Ka is not included. We must go to the data booklet to look up that value. The Ka of ethanoic acid is 1.8 times 10 to the power of negative 5. 1.8 times 10 to the power of negative 5. We're going to take that Ka, acid equilibrium constant, and multiply it by Ha, which is given to us here in the question, 0.83 moles per liter. Take this and multiply by 0.83 moles per liter. We're going to do that operation. 1.8 times 10 to the power of negative 5 multiplied by 0.83. We're going to take the root of that answer. We have 0.00386,523. We have the concentration of the hydronium ions, which now we must convert into the pH. The pH is equal to the negative log of the hydronium ions, which means we're going to do the negative log of our answer down there, 0.00386,523. This value that is already on our calculator screen. I'm just going to continue with that. It's the negative log of that answer, which is equal to 2.412824,701. We have our raw answer. When we go back to look at the question, there's only the one number, 0.83 moles per liter. That has two significant digits. And this is a pH. We want to express this pH with two significant digits, which means 2 decimal places. So this is 2.41. And pH does not have units. When we're being asked to solve for the hydronium ions, Ha, or the pH, we want to use this version of the acid equilibrium formula, manipulate it. We're going to have to go and look up the Ka in the data booklet, and from there, follow the operations where they lead us. There's always this extra step to use the log-based formula to turn it into a pH, and once more, be careful with your significant digits. And I hope that helps.